And this is problem 2 from the AP Calculus 2022 free response portion. It says, let f and g be the functions defined by those two formulas, ln of x plus 3 and x to the fourth plus 2x cubed. Well, since this is a calculator question, I'm just going to go ahead and type it in, because I may not need it in this section, but I will probably need it in problems to come. So helpful just to have it there at the ready. Okay, it says find the area of the region enclosed by the graph of f and g. Now they give us this intersection right here, but we're going to have to find that intersection. Now the graph tells us that we should change our window, and it should be between -2 and +2. And then we'll zoom fit that. There we go. Actually, I think we can probably take our window down to 1. And I think if we zoom fit that, that'll be a little bit better. Yeah, that's a bit better. All right, so now they do tell us right here that they intersect at -2 and x equals b. So we have to find where b is. So we're going to use our intersect command. And okay, so my x's are way too far out. So there we go. Press enter. It's right there. So the intersection is whoops, 0.78198. That's what b is equal to. Now for the rest of the problem, I can just save b as that number, and it's all good. Now we want to find the integral that gives us the area between these two curves. So we have f of x on top, and then we have g of x on the bottom. So from -2 to b, we have f of x minus g of x dx. So we will go down to integral from -2, and now we type in 0.78198, and now we have to subtract our values, y1 minus y2 dx, and press enter. We have 3.60, and we're going to round, so that's 0.604. That's the region of the area enclosed by those graphs. Now in part B, it said let h of x be the vertical distance between the graphs of f and g. So let's make a note of that. So that means h of x is equal to f of x minus g of x. So we'll just make a note of that. Then it says, is h of x increasing or decreasing at -0.5? So is h of x increasing or decreasing? Now, a related question would be, is h prime of x positive or negative at x equals 5? So what we can do is we can find the derivatives of these two, or we can find them all together. So under y3, I'm just going to call it y1 minus y2. And so that's our h of x right there. And so I'm going to find the derivative of this function, y3, at this point. So I go down to number 8 and derive. And so we have y3 -0.5. Let me press enter. So that means h prime of -0.5 equals -0.5 0.6. So that means h of x is decreasing because h prime of negative 0.5 is less than 0. So there's our reason. Now part C, the region enclosed is the base of a solid. So we always tend to have one of these volume type questions where the cross-section is a given shape. In this case, our cross-sections are squares. That's what they tell us. And they are perpendicular to the x-axis. So just like this. So one thing I usually do is I usually label these points x comma f. Nope, that's not f of x, that's g of x. And then up here we have x comma f of x. So then what I do is I draw a picture of the square over here so we can easily see that we have x f of x and then x comma g of x. And so the length of this is f of x minus g of x, or we can just use h of x from the last problem. Now I don't know if AP would take kindly to that. I mean, they're the ones that made up the h of x, but it's possible that we have to go back and use the f of x minus g of x notation. Either way, the area is f of x minus g of x squared. The volume is the integral from negative 2 to b, capital B, of f of x minus g of x squared dx. So what we can do is we can actually go back and recycle over here on my calculator. Press second enter. I can just recycle that and just put in an extra parentheses. One more won't hurt. And all I have to do is just change this and square it. And so what we get for our volume is 5.340 for our volume. And then the last part, it says a vertical line in the xy plane travels from left to right. The vertical line is moving at a constant rate of x units per second. Find the rate of change in the area of the cross-section above the vertical line with respect to time when the vertical line is at position x equals negative 0.5. This one is really hard for people to imagine. And what I like to think about it is, think of it like if you've ever looked at a copier machine. Just imagine that it's kind of scanning. Just imagine that beam of light as it passes underneath. And what it's doing is it's lighting up each cross-section. And that square is being lit up. Now we can use the area formula that we did in the last problem. Area equals f of x minus g of x quantity squared. Now here's the key thing. It says find the rate of change of the area with respect to time. What that means is we have a related rates problem. We're no longer taking the derivative with respect to x, we're taking the derivative with respect to time. So our derivative is d area dt. So that means x is changing with respect to time. Now the good thing is we've got that part covered because it says it's moving at a constant rate of 7 units per second. I'll show you where that plugs in a second. But for right now, this is chain rule. So the outside function is squared. So we have 2 quantity f of x minus g of x times, now we have the derivative of the inside, times f prime of x minus g prime of x. And then we multiply by the derivative of the inside of that. Well, what's inside of that? X. Why do we need that? Because it's changing with respect to time. So we have dx dt here. So that's where this shows up. All right. So now what we can do is we can fill in some of these numbers. Now actually, this right here, I believe we already have the answer for that. If we go back to part B, there it is. We found h prime of negative 0.5. It's negative 0.6. And usually AP likes to do this, is they'll have callbacks to previous parts of problems. So negative 0.6 times 7. And then we have 2 times, so this is the part we only have to calculate, f of x minus g of x. And we can use h, because that's what that is. So if I hit trace, negative 0.5, enter. And it doesn't give me the formula for h of x, but that's okay. We can do this another way. y3, parentheses, negative 0.5. We get 1.10379073 and so on. So we're just going to pile all this into the calculator. So times 2 times negative 0.6 times 7. And so our answer is negative 9.272. And it's a change in area. So it's units. So units squared per second. Is it? Yep. All right, good. All right, thanks for watching. If this helped, give it a like button and subscribe to see all the other videos we've got coming out. I'll see you on the next one.